All right, on to another video. We left off with iterators, so we're going to dive into that and discover that. I'm still kind of fascinated by the whole maps thing when I discovered that in my last video, so transition is over. If this is the first video you've seen, I have W3 schools on the right, VS Code on the left. These videos are about me discovering things about C++, help me to learn C++. If they help you too, that's great. If not, Uh, you're welcome to leave comments, questions, or whatnot in the comments. If you like the videos, hit the like button. Get started with iterators. Now, I've heard about iterators, just never really dealt with them too much. So let's see what they're about. Iterators are used to access and iterate through elements of data structures, vectors, sets, etc. by pointing to them. It is called an iterator because iterating is the technical term for looping. To iterate through a vector, look at the following example. So we have an example here. Go ahead and clear out this code so we can get this example put in here. And this is using vectors, so we're going to need the vector library. So let's change out this library here. New vector. Oops. Okay. Got some comments here. We'll go ahead and put the comments in first. Create a vector called cars that will store strings. So standard vector standard string cars is assigned to, and then we're gonna do the list right here like I've been doing. Adjust this a little bit. So we got Volvo again. Comma. We got BMW again. Ford. And Mazda. And then in the vector there. And we got another comment here. Create a vector iterator. Again, iterating is just another term used to loop through, right? Yeah, technical term for looping. Create a vector iterator called it. Iterator, so don't forget, is a, actually no, I'm going to put this down below. Oops, there we go. So, iterator is a technical term for looping. So, standard vector, standard string iterator it. Now, I don't recall it saying anything about using the actual word iterator, and since it's underlined, I'm going to say that we actually need standard in front of it. Standard iterator it. And got something wrong here, so let's see. What's this say here? Just checking to see if I got this right. I got some an error here. Class. Do we class standard vector string standard iterator allocated string has no member iterator. So I was thinking maybe we need a library for this, but it's not really showing one. Standard, and that doesn't work because then it doesn't understand what it is. Maybe standard it. Nope. Okay, so the only way to fix this or understand this, since it doesn't really specify how we're going to use iterator in this, is to see the example that they're using. They have standard right there, iterator it. Create an iterator named it. Ah, I got it misspelled. Huh, that's why. Maybe if I spelled it right. Yep, if I spell it right, it works. All right, so we got that. Moving on, we got a loop right here. Loop through the vector with the iterator. So the for loop here with it set to cars dot begin. I'm not sure if we've discussed begin yet. It's not equal to car, not equal to cars dot end. I don't think we've used end either, but I'm not sure. So, and then increment it. and then we got the curly brackets with an output. Pointing at it. There we go. So I don't recall using begin or end with anything yet. So that is maybe new, but going through the sources again as if it may kind of describe that, or going to my other sources. But we have created a vector here, a list of cars. We have created a iterator called it, which is a technical term for looping. I'm not sure what this means. It doesn't give a whole lot of detail on that, but yeah, okay, so I see it down below. It's going to explain it here in a minute. We've got a for loop here. It is going to be set to cars for the beginning. It is not going to be set to cars at the end, but we're going to increment it. Okay, so let's go ahead and save this, run this, and see what we get, and then look at the explanation of this. So we are looping through and going through all the cars. We've done that before with a standard loop, but this is different because it's an iterator. Example, explain we first create a iterator, a vector of strings to store the names of different car manufacturers. Then we create a vector iterator called it that we use a loop through the vector. Next we use a for loop to loop through the vector with the iterator. The iterator it points to the element in the vector cars.begin, and the loop continues as long as it is not equal to cars.end. The increment operator moves the iterator to the next element in the vector. The dereference operator accesses the elements the iterator points to. So Some of those things I've not seen. That's kind of confusing since I'm not used to seeing it that way. But that's fine because I've discovered it now. Using it more, seeing the explanations more will help me to understand it in the future. For now, we know it works because it does what the example here shows. So I know I got it typed out and I know everything's working on my programs. So note the type of the iterator must match the type of the data structure it should iterate through. String in the example. So this type right here has to match this type up here. So if you have it set to strings, it's going to be set to strings as well for the iterator. I'm not sure, so what I'm confused about or don't understand, I'm not sure what the iterator is actually doing here because I'm pretty sure that you can do the same thing with index. I is not equal to, but I'm not sure since I'm not familiar with this right here and there's not a lot of explanation in there. But now we're going to discuss what begin and end mean. So what is begin and end functions? These are the begin and end functions that belong to the data structures such as vector and list. So it's part of the library for vector and list. They do not belong to the iterator itself. Instead, they are used to iterate with iterators to access and iterate through the elements of these data structures. Begin returns an iterator that begins to the first element of the data structure and returns an iterator that points to the one position after the last element. So to be able to use, I'm assuming this if I understand it right. In order for this right here to work, to access each index and whatever's in each index for the variable, so what's in this box right here, you have to use iterator to loop through it and use this right here to point to whatever the values are in each box. The box is indicating the index number 0 through 3 in this case. To understand how they work, let's continue to use vector as an example. So we got another one right here. Same thing. So begin explains, or sorry, begin examples. Sorry. Anyways, begin points to the first element in the vector, index 0, which is Volvo. So we're using the indexes, and begin is using uh, the starting point, which is 0, and is using whatever is in the last spot. And it's going to continue doing that until it gets to the end. Once it gets to the end, it's going to jump out of the loop. The example, it is set to cars, points to the first element in the vector. So it set to cars.begin, it's the first element in the vector, using it as the iterator and using the dereference of it to point to whatever's in that location. To point to the second element, BMW, you can write cars dot begin plus 1. So if we wanted to point to a specific element, we would change this right here to cars dot begin plus 1. I assume. It has that. I don't know if that's needed or not. Which is the second element? It. Okay. So you actually have to set it to that. So you would still have the dereference it. And then. Oh, this is in the loop. That's why it won't work. Okay. So we'll go outside the loop here. And set it to cars dot begin parentheses plus 1 and then standard output. Now you probably have to get rid of the for loop in this case. Yeah, so let's get rid of that just in case. Okay, and then dereference it. Oops. It'll save, and it should just print up the second one, BMW. Yes. All right, moving on. If you want to do the second one, you would just change this to 2. So for each one, if you wanted to just point out to 1 or 2 of them and stuff, then yes, you would use the iterator it and dereference it. And that way you can use this right here section to indicate which one you want to do, but you would not put the number in the begin because the begin function starts at the beginning. You would just add to it. So this right here is automatically set to 0. What if we went ahead and changed this to 1? What would that do? That would not do anything. That would actually create an error. Okay. So example end, or the end example, end points to the end position. So I'm assuming you would do the same thing with end, but instead of +1, you would -1. So end -1. Save, and that should be Ford. Nope, it's Mazda. Because the last one would actually be whatever's empty. So if we wanted Ford, we'd have to do 2. Yep, okay. So in the beginning one, if you left it empty with nothing added right here, it would point to the first one. But when it comes to end, you need to subtract 1 because it points to, eventually, the last one ends up pointing to nothing. So if we left it blank right there, saved it, and then ran it again, there would be nothing there at all. In fact, the program's probably trying to still run. Yeah. Because there's nothing in that location, so this gives you a bunch of nothing. Close that out. So we'll put it back to -1. Save and run that. I don't know what all that was and stuff in the terminal when I didn't have anything in there, but why do we say point? Iterators are like pointers in that they point to elements in a data structure rather than returning values from them. They refer to specific positions, providing a way to access and modify the value uh, when needed without making a copy of it. For example, so we got another example here. Let's go ahead and get this one in here. We're still going to have the iterators in there, but we're going to change this to it set to cars dot begin parentheses. So that one's going to point to the first one if we output it standard it dereference it. Run it. Points to the first one, which is Volvo. But if we want to modify it, actually, let's put a space in there. So dereference it and set it to Tesla. And then output it again, and we'll get Tesla this time because we're changing what's in that location. Actually, we don't need all that. We just need that right there. Save, run. So the first time it's going to print Volvo. The second time it's going to print Tesla, even though it's pointing to the same location both times. It's pointing to the same location both times because of this line of code right here. But we're changing it the second time it outputs because of this right here. Changing what's in that location. the auto keyword. In C++ and later versions, you can use the auto keyword instead of explicitly declaring the declaring and specifying the type of the iterator. The auto keyword allows the compiler to automatically determine the correct data type, which specifies the code and makes it more readable. So where we have this right here, instead of having this, we would change it to simply auto. It is cars dot begin parentheses end, and you're doing pretty much the same thing, it looks like. But then again, we're asking the question, why wouldn't you just use this over the other one? This is a lot easier to type, a lot easier to read. If you want to, if you have, I don't know. I'm going to just say that right now. I don't know. In the example above, the compiler, well, this example right here, the compiler knows that the type of it is based on the return type of cars.begin, which is vector string iterator. The auto keyword works in for loops as well, so we can add a for loop and do the same thing. To where instead of all of this, you would just create the for loop. Here, let me go and get rid of this comment as well. For auto, it is cars dot begin parentheses. Oops. Well, it is not equal cars dot end parentheses semicolon increment it and enter curly brackets and then output dereference it and then run that one. So it does the same loop with auto. The first one, you're basically making sure it's got the right, it's pointing at a vector, pointing at the type in the vector. So if you have multiple vectors, then you gotta, then you might have issues with the auto keyword it, but it's still pointing at the vector name. So there shouldn't be too much of an issue. Sorry. Anyways, for each loop versus iterators, you can use for each loop to just loop through elements of a data structure like this, which I think we've done that before. Simply put, it is actually this, yeah, almost the same. Actually, what we need to get rid of is this right here. So we change this to standard string car. Like I said, I think we've done this before. There, change it to car. Save it, run it. Move that out of the way. Get the same result. When you're just reading the elements and don't need to modify them, the for loop for each loop is much simpler and cleaner than iterators. However, when you need to add, modify, or remove elements during iteration, iterate in reverse, or skip elements, you should use iterator. We got another example of that right here. Got the same vector, but this time we're changing the for loop for this example to auto. It is cars dot begin again. It is not equal to cars dot end parentheses. Actually, no, it's the end of it right there, because so we got the for loop right there. We got this here, oops, enter, if the this is for each loop or for if loop, did it say? I can't remember. This is for each loop, so the if, so if dereference, oops, dereference it equals BMW, which is the second car on the list, and enter, it is cars dot erase, so we're erasing BMW out of there, looks like, parentheses it, in that comment, remove the BMW please, it's in the way. Else increment it, and then the printout, which is so that one goes to that one, that one goes to that one. No, that one goes to that one. I was looking at the curly brackets here because their curly brackets are not colored, so I'm trying to determine where this should be. That's a curly bracket. There's another curly bracket right there, but that one ends right there. That one ends right there. So that one ends right there. So this is outside. So okay, so we're creating another for loop. What we're doing. Let's get rid of this output right here. I don't think we need it. Outside of this for loop, we're going to create another for loop. Comment here, print vector elements for const standard string location cars, and enter the loop output car new line. And okay, yeah, because we don't have it in there anymore. So we've got that. So save. So this one right here is going to loop through it and remove BMW. It looks like. So we're gonna loop. We're not even gonna loop through it. It's gonna look for if it is BMW, it cars erase it, which is gonna remove BMW. Once it's going to keep looping through this right here until it finds BMW to remove BMW out of it. And once it's BMW's removed, basically can't go through the loop anymore. It's going to jump out of the loop. So when this is false, it's going to do this. When this is true, as it keeps incrementing through it, no. When this is true, it's going to remove it. When this is false, it's going to jump down to this right here. When it's, do we have? Didn't see that. No, we don't have that. So I'm not sure exactly what this loop is doing. Since we're not incrementing up here, we're incrementing down here. But this is set for the if right here. So this loop is going to continue running, but I'm not sure when it's going to break out, when this is false. But either way, maybe my other source would kind of help me out with understanding that. So I'm going to run this, and we're going to basically, I understand it's going to remove BMW. I just don't know how. I can't see how the loop's going to run. But we're going to remove BMW. I guess while there's still cars in there and stuff, it's going to keep looping until it's done. So if you had two BMWs in here, let's go ahead and add another BMW. It would remove the second BMW as well. I believe it would end up removing both BMWs. Yes. because it's going to keep looking through the loop and stuff until it gets to the end, and it's going to remove every time it's BMW. Get rid of all your BMWs in your parking lot. You got to remove them all. I guess this is the code you would need for it. Iterate in reverse. Now, if you want backwards through it instead of forward through it, which is the way the first one was going, do it that way. If you want to do it backwards, you would change this for loop to R, reverse, begin. I'm guessing that's what that means. So to create an iterator in reverse order, you can use the R begin and R end instead of begin and end. So all we're going to do is change this, and it's going to be reverse end, reverse begin. So it's going to start from the back and go forward through it. Now, in this case, we don't need, it's just going to print them off, so we don't actually need this entire loop right here. We're going to take this right here and put it up there. Get rid of this loop. It's just going to loop backwards through it now, printing off each one back in reverse. I'm going to change this to dereference it. Save, run. It'll print them off backwards. Actually, it won't stop because we didn't have the incrementation in there. That's why we need to increment it. Now let's try it. There we go. So it's going to print the first one last and the last one first. I forgot to increment it. Okay, iterate through other data structures. So if you want to do other data structures like string, query, set, map, you could do the same thing as you did this way right here with the iterator. So we basically, I mean, this is going to all be set up the same and stuff. We just change this up here from a vector to a list to a query to a stack. I'm not sure if it would actually go through a stack or not like that, but query, it shows map, set, to query, list, but no query. So, iterator support. The examples above show how to iterate through different data structures that support iterators, vectors, list, to query, map, set. So query is not supported. I think an array probably is as well. I think it's supported. So the only one so far we've gone through that is not supporting the iterators is the stack and query. And that's because you cannot randomly access particular parts in those. I guess. Or the code's just not written for it to do that, maybe. I don't know. But it says we can't do that with that one, but we can do it with the rest of them. Stacks, queries are obsolete for iterating, period. Algorithms, which is the next thing we're going to go to in the next section, as well as this section right here. How much longer is this? I think we'll probably start with algorithms in our next video. So yeah, we're using, basically in this video, we've discovered iterators and how to use them, which there's a slight bit of difference between iterator and auto, or as a type, I don't know. Like I said, my other source is probably going to help me understand a little bit better what this is, but there's a few things we've discovered, so we know about it. That's the key point in all of this, is knowing about it first, understanding it, the more we use it. So if you like the video, hit the like button. If you have any comments or questions, again, put them in the comments. I will catch you in the next video.